Hey, Jeannie.
Yeah, Brew.
Who's our guest on the Energy Nerd Show today?
Today we have Cecilia Springer, who is a principal at Synapse. Hi, Cecilia.
Hey, Dr. Springer. Welcome to the show.
Hi, Bruce. Hi, Jeannie. Thanks for having me.
It's good to see you. So what are we talking about today?
I'm hoping to talk about the industrial sector and how to decarbonize it in the U.S.
That would be amazing. We have to do it. Yeah. So
sounds hard. How are we going to do that, Cecilia?
I think the industrial sector is often given a bad rap of hard to abate. That's the term that gets bounced around a lot. Of course, it's challenging, but I don't love calling the industrial sector hard to abate as opposed to buildings, the power sector, transport. There are so many other things that all have their challenges and their opportunities. So I don't like to see it singled out, but it is very important. The industry sector makes up 30% of U.S. energy-related CO2 emissions. So we definitely can't ignore it. And I'm really glad to have joined Synapse last year and gotten to work on a lot of exciting industrial-related projects.
Yeah, I'm glad you're talking about this. And when you think about the old building stock that we have and so many small buildings, so different, with such different characteristics, and then you're going to be talking about industrial, supposedly bigger customers. I know may not be quantifying this right now, but could one actually say it might be easier to abate in the industrial sector, or is it's not simple either way?
I think it's hard to say. I think every industrial facility has its own story, probably, whereas buildings, we could potentially say that they're all a little bit more alike to each other. But it really depends on what's being made in an individual industrial facility, what they're manufacturing, what sector they're in, what temperatures are required for the heating that they use to make their products. It's interesting that you mentioned buildings, though, because I think there are some shared solutions between the industrial sector and the building sector, especially when it comes to relatively lower temperature heating. And a key solution is electrification of that lower temperature heating. So in the building sector, many Synapse colleagues work on heat pump adoption to help people heat their homes with heat pumps instead of gas boilers. And you can do the same thing in an industrial facility at a larger scale and with slightly higher temperatures. So the technology is not exactly the same. There are some modifications to be able to produce steam instead of hot water or hot air at temperatures up to about 200 degrees Celsius, but it is a technology that's in early commercial stages that has a lot of similarities with buildings.
Okay. And just for framing, what industries should we have in mind as we're learning this today?
So temperature ranges that I'm talking about are relevant for industries like pulp and paper manufacturing, which we have in the US, food and beverage manufacturing, which is important for a lot of states in the US. There's also textile manufacturing, which is more relevant for some other countries around the world, especially in Asia. And what are some other lower temperature industries? I think that covers some of the main ones for the US.
And so today we're talking a lot about electrification and a lot about heat pumps, or big heat pumps, right? Not the little residential heat pumps, but larger heat pumps to electrify industrial processes?
Yeah, industrial heat pumps. You could also call them high temperature heat pumps or steam generating heat pumps.
All right. So is this conversation based on your recent work? And I mean, I know you've been working in this field for quite a while. And is there anything recent that you've found or
Did you bring a graph to talk to us? Can you show us a graph?
Yeah, I think a really good starting point that demonstrates why industrial electrification is so important to Synapse is the spark gap graph. And I think that the graph that will show the data, there's a little bit updated data from the Energy Information Administration, which actually makes the picture a little bit worse. So the spark gap refers to the ratio of the electricity price to the fuel price, typically natural gas, which is what we're showing in this graph, for industrial facilities. And in the graph that we'll show, we break it out by state, but it can vary even at the facility level. So most facilities now burn natural gas for their process heating, which makes up, in some of those industries I just mentioned, like pulp and paper and food and beverages, that makes up the majority of their energy use, emissions, and energy related costs. So the energy source that they use for that heating is mostly natural gas. Natural gas is historically cheap in the US right now. And so this is the fundamental challenge to electrification. Electricity is much more expensive than natural gas. And you can see how it varies by state. So some states have more favorable spark gap conditions, but even beyond the state level, that will vary within the utility territory. It will vary based on the rates for the industrial facilities. So a lot of our recent work at Synapse comes down to this unique intersection between the industrial sector and then electric rate design and how electricity is priced for industrial facilities. And we have a couple of reports on that.
So just on this graph, if we see like the spark gap is 4 or 4 to 1, that means that for that state, electricity is 4 times as expensive as gas per unit of energy delivered to the meter. And then because heat pumps are like magic and have efficiencies higher than 100%, that can help to overcome these price differentials.
That's right. Yeah, so heat pumps are not magic, although I like that you called them that to bring a bit of whimsy to the technologies that we're working on. But a typical natural gas boiler would have an efficiency ranging from maybe 75% to 90% in terms of its ability to convert chemical energy in combustion fuels to thermal energy for that heating that industries need. But heat pumps can have an efficiency of 300%, 400%, or even higher. And that's not because of magic. It's because using electricity to transfer heat rather than generate it. And in the industrial sector, they can use waste heat and then use that to further increase their efficiency. Efficiencies are lower for the industrial sector than what you would see for heat pumps in houses and apartments, for example, because the temperature lift requirements are higher, but they still are way more efficient than those boilers.
So from this graph, we can see like some states that are very attractive for industrial electrification and some that are less so. Is it?
Yeah, I think that's what we see generally across states and, even at the sub-state level. Yeah.
And then these are like average rates for the state and average all-in prices that they're paying and don't reflect the detail. You're starting to talk about rate design, and these don't reflect any sort of innovative rate design necessarily. They're just the average prices. Is that right?
That's right. This is just an average annual price of electricity and natural gas taken from the Energy Information Administration, just to kind of get a sense of where the opportunities might lie. But the reality, and one of the reasons that we're working in this space, is that the actual spark gap can vary a lot based on the specific rate structure for that facility. And that's something that we recently dove into head first to try and understand what that actual spark gap is and how it could potentially be changed or hopefully be overcome with different rate structures.
So what are the solutions there?
Recently, I had the opportunity to work with some other Synapsers who are experts on rate design. But what Synapse has been exploring in the realm of rate design to incentivize industrial electrification is rates that incentivize load flexibility, so that if industries are able to shift their electric load post-electrification, they can really lower their electricity bills, taking advantage of new rate designs that have, for example, time differentiated rates with lower energy prices during off-peak hours, or alternative demand charges so that electricity is more expensive when the grid is strained and less expensive when it's not. We also looked a little bit at special electrification tariffs that can offer targeted discounts for new electrified load. So those are some of the mechanisms we explored, and we actually quantified their impacts on reducing electricity bills for industrial customers.
Are these big customers already paying time of use rates, or would that be a new concept for them?
It depends on where they are. So in the past year or so, we've looked at a couple states, California, Colorado, and Illinois. And within those states, each utility would also have its own rate structure for industrial facilities. So it just really depends on where the industry is. And some of them have time varying pricing, and some, my understanding is, do not.
And how much work does that take on the part of the plant manager or kind of the on-site people? Is it sort of business decisions that are made and then everything's automated, or is it more, I don't know, it might be a learning curve for some operators to make decisions that they don't have to make right now?
You mean in terms of how their electricity is priced?
Well, and how to, if they have to alter their operations in some way in order to take advantage of the prices.
Yeah.
Right. Like, are they aware of, or do they have experience with making their processes more flexible?
Yeah.
Right. Are they shifting load now? Or, I mean, because I know there are load reduction opportunities now, but not for everyone. So.
Yeah. So, I mean, I definitely think that is a big challenge for industries, and they tend to push back on the idea that they could just easily switch off their equipment at this hour and turn it back on at the other hour. The reality of a lot of industrial operations is that they have relatively more constant load, especially in certain sectors like pulp and paper or chemicals. They're operating something more like 24/7 than a factory that opens at 8 a.m. and closes at 5 p.m. or something like that. So that's definitely a consideration in terms of their ability to take advantage of those alternative rate structures. But one really cool technology that we also explored was thermal batteries. So like electric batteries, they charge when electricity is cheap, and they can discharge at any point, really. But for thermal batteries, they don't discharge electricity, they discharge heat. So they can directly provide that steam that's needed for industrial processes. And I really think, while heat pumps are magic and wonderful, thermal batteries are also really important to talk about.
So tell us more about the thermal batteries. What's that technology like?
So thermal batteries use electric resistive heating to take electricity either from the grid or it could be from on-site sources and charge a material that has really good heat retention properties. So think like brick, there are certain types of crushed rock and other materials, and they heat it up very high temperatures, above 1,000 degrees Celsius, and store it actually with pretty high efficiency, like very high efficiency. And then that heat can be used on demand. Thermal oil is circulated and used to generate steam, which then can go straight into the facility's existing pipes and networks for delivering that steam.
Cool. How do they compare size-wise to other batteries?
That's a good question. What I've heard about the thermal batteries that are just starting to hit the market today is that they can be scaled up or down. They're pretty modular. So if you think of like one box of hot rocks, or you could have 10 boxes of hot rocks, and that can get you up to the tens of megawatts scale. And my understanding is that I think there's a project around that scale being deployed now in the chemicals industry.
Cool. That could definitely be a brand name for some of those thermal batteries.
Yeah. No, there are companies, I think they have more sophisticated names, like Rondo and Antora come to mind and are slightly more glamorous than hot rocks.
I like hot rocks. Cool. And what about the recent analysis and blog post that is up on the Synapse website? What were your inputs? What were your findings?
Yeah, so I think we had been thinking about what does affordability mean for industrial energy users, because everyone is thinking about energy affordability right now. And we know that industrial customers haven't really been at the forefront of that discussion. We're thinking a lot about, for good reasons, data centers and how do they impact people like you and me, but also industries are struggling. And electrification could seem like even more of a pipe dream if electricity becomes even more unaffordable. So we were looking at, what's the big picture and what we're finding across some recent Synapse studies on the spark gap and how alternative rate structures could help industries that want to electrify. So in the blog post that you mentioned, we profiled results from 2 recent reports. One was on California, with a shout out to the Sierra Club, Industrious Labs, and ACEEE for co-authoring that study and also being our client for that study. So on California, we looked at natural gas bills for industries for their heating before electrification, and then electricity bills after electrification with either current rate structures or the alternative rate structures that Synapse is proposing. And we found that in that specific case for California, that the electricity bills would be much higher than the former natural gas bills under current rate structures. So they're getting the same heating that they need for the industrial processes, but if you electrify without changing your rate design, your energy bills will go up overall. However, with the alternative rate structures, they could come down a lot, but not necessarily all the way down to the level of the original natural gas bills or even lower. So that is a challenge, indicating that other measures are needed to support electrification. What we found in another study is, this was for Colorado and Illinois, working with the Center for Applied Environmental Law and Policy, was that in some cases we could actually reduce electricity bills even further than previous energy bills with electrification paired with that alternative rate structure. But what we found there was another barrier, which was capital costs and installation costs for the electrification technologies. So we took a little bit more of a lifetime cost approach to look at costs for facilities, taking into account not only their energy bills, but also the capital and installation costs, operation, maintenance, and so on. And especially for heat pumps, those capital costs can be a major challenge. Just the equipment that's available today is quite expensive. And installing it is also an underappreciated expense. And so again, even when we're able to sort of flip the economics of the energy itself, there's still work to be done and policies to be passed related to supporting some of those CapEx requirements.
So, Cecilia, thanks for being on the show. It's great to have you. It's really interesting hearing about this. Is there anything else you want to talk about while you're here?
I guess I would just highlight, I think one of the really exciting things that the Synapse team has done is we've built an in-house tool that could theoretically evaluate electrification for any large industrial facility in the US. And I mentioned the 3 states that we've applied it on so far. We also have forthcoming work on some other states and regions in the US, but we're really ready to go nationwide with this. And for the Colorado and Illinois study that I mentioned, we linked it with thermal batteries, and their hourly charge and discharge profile for the first time, because I think that's something that industrial customers are really getting interested in, this ability to arbitrage their energy and electricity pricing. So I think we have some really cool modeling work, and you can read about it in detail on our website, and we hope to just share more and more about that in the coming months.
And as you expand into other states, who's the ideal client? Is it state agencies or is it nonprofits, advocates?
Or industry itself?
Yeah.
That's a fun question. I would love to work with state agencies that are trying to map out pathways for their industries and especially their lower temperature electrifiable industries so that we could think about sequencing and how the costs vary from facility to facility because our tool can get down to the facility level, which is really cool, and see which facilities have the most arbitrage opportunity if they're able to flex their load. And yeah, I would love to work with industries themselves. I think helping them get the big picture on their opportunities, the lay of the land of the different technologies that might be available, both low temp and high temp. I think that would be really great. Or even for more industries like food and beverage, where the brands also play a large role in sourcing from these factories, potentially working with those brands that are more sustainability minded and are starting to think about heat and emissions in their supply chains. I think that'd be really cool.
Cool. Well, hopefully after they hear this, they'll be calling you.
I hope so. Yeah. We can put my number in the show notes.
Yeah. Wait, I have a crazy question. Where foods are labeled organic or, with the European versions of that, is it ever required or part of that branding process to be that they are not using a lot of fossil fuels in their processing and packaging and all that?
I want to say there have been voluntary labeling efforts that I've seen around this. And probably the EU is more advanced than the US. I don't know if there are any global mandatory carbon related labeling requirements. I'm trying to think, and I can't think of any off the top of my head. I think if anything, actually the textile and apparel industry is ahead of food and beverages on this. I think they have a little bit more of that consumer awareness and pressure, a little bit less of the complexity of like food safety and that kind of thing. And so I think I've seen, maybe it was H&M saying they're working on having a net zero garment or something like that. So that I think there's a little bit more, from apparel brands that are thinking about this, or they might say a tag that will say, this t-shirt was manufactured without fossil fuels or something. I think those are kind of coming, but they're voluntary for sure. And could be more in the advertising realm than like reporting your required footprint.
Yeah. Very cool. Well, it's really good to see you, and it's fun to learn about this work. Thanks for being on the show.
Thanks for having me.
Bye, Cecilia.
I'll see you in May and before.
See you.
See you.
All right. Bye.